Dear students, welcome back to Study with Adu. Here, Adu. Please like, share, subscribe the video. Subscribe to my channel. Share, like the video, share the video to your friends. Comment your opinions, doubts, suggestions, etc., etc. So now we are going with the part 4. That is, we completed everything, every reaction on aldehyde ketone in the last part. Now we are coming to the next chapter, a short part of the same aldehyde ketone chapter, that is carboxylic acid and its derivatives Stop. It's a small part in the same chapter. Okay, first of all, preparation. We'll go fast because it's very simple. Every reaction we have once saw somewhere or the other. First is from alcohols and aldehydes. You know that if we oxidize alcohols and aldehydes, we get the corresponding carboxylic acid. So I am taking first from alcohol, taking an alcohol and I am adding strong oxidizing agent, that is acidified potassium permanganate, alkali KMNO4, etc., etc., strong oxidizing agents, and if we hydrolyze, we get the corresponding carboxylic acid. Simple, right? Simple. We can also use which all reagents we can use? K2Cr2O7 and CrO3 in acidic medium. The CrO3 in acidic medium is called Jones reagent. This is very important. They can give you questions like this. So I am giving you a question: CH3 CH2 8 times CH2OH, Jones reagent. If this is given, you should know that Jones reagent is taken, that is CrO3, and you should accordingly write the answer as CH3 CH2 8 times CH2 8 times COOH. Should understand this and write. Okay. If you want to prepare alcohol or carboxylic acid from aldehyde, use Tollens reagent. You can use Tollens reagent. Use Fehling's solution. Mild oxidizing agent. You can use any of this. It will automatically convert it to RCOH and hydrolyze it. Use this first, then H3O plus, then you will get RCOH. This is the reaction from aldehyde. From ketone also we can prepare, that we have seen, that is CH2 C double bond O CH2 R dash, that is extreme conditions we will get accordingly, plus R dash COH, or the vice versa we can get. This is also possible, but in very extreme conditions, that is not normal room temperature and all, high pressure, high temperature, extreme condition only it will happen. Okay, now from alkyl benzenes, this is mainly preparation of benzoic acid from alkyl benzene. Take anything, toluene, or take CH3 cumene, CH3 take cumene, take cumene, any hydrocarbon, any aromatic hydrocarbon, and add not benzene, anything should be substituted to it, KMNO4 and KOH, and heat. First step. Then second step I am directly writing hydrolyze. Then you will get the corresponding corresponding acid you will get benzoic acid. No need of corresponding acid and not benzoic acid. If it is this cumene also, you will get what? 1 it will be KMNO4 KOH heat 2 H3O plus. What do you get? Here also you get this product. So this is important. From alkyl benzene, take any alkyl benzene and add KMNO4 KOH heat and hydrolyze it. You will get what? Benzoic acid. Now third one from nitriles and amides. From nitriles and amides. Nitrile means what? Cyanides. Into cyanide you add H plus or OH minus. That means you just hydrolyze it, or add acid medium or basic medium and add water into it. It automatically converts to amide. Okay, amide. Into this amide you add H plus or OH minus and heat it. Then we get the corresponding COH. Okay. Or you can directly take an amide, RC double bond NH2, and you can hydrolyze that amide. Hydrolyze the amide, you get the corresponding hydrocarbon. Simple. You can take what? Benzamide also, that is RC double bond NH2, and you can what? Hydrolyze. You get what? Corresponding not AR. One second. Okay, you will get what? Here you will get benzoic. I'm getting angry, I don't know why, but okay, here we are getting phenyl ring COH. Yes, benzoic acid. You are getting benzoic acid. Okay. So corresponding, if you hydrolyze amide, you get. If you are using cyanide, first hydrolyze it into amide, then hydrolyze it into RCOH. Okay. Now next step is 4. From Grignard reagent, look, everything, aldehyde, ketone and whatever carbonyl compound things can be prepared from what? Grignard reagent. Grignard reagent is like a king. Grignard reagent. First of all, take a Grignard reagent, RMGX. Into this Grignard reagent add carbon dioxide. This is carbon dioxide structure in dry ether medium. So what happens is that carbon dioxide is like this. What happens is that carbon, 2 oxygen and 1 double bond break, and that will be going to this R, and the rest is O minus MgX, O minus Mg plus. Okay. If you hydrolyze the same, what we get? We get RCOOH. Okay, understood? Yes. This is from Grignard reagent. Very simple reaction. Directly you can write the reaction. RMGX 1 CO2 2 what? 2 H3O plus. Answer will be RCOH. Very simple. Directly you can write. Okay. Now next reaction, 5th one. From acyl halide and anhydride. Anhydride, you know what? Acid anhydride. Simple. Take acyl halide, that is ROCl. This is the acyl halide. This thing, and add water or hydrolyze. We get RCOOH plus HCl or plus HCl. Or you can add a base also. That's if you add a base into it in water medium also, the same happen. You get RCOOH. Here they have given Cl minus. We'll give it Cl minus itself. That is good. Okay, Cl minus, and once if we, this is not this, we get minus. Okay, if we hydrolyze it only, it become RCOH. This is from ROCl. Now from anhydride. Okay, it is C6H5, any anhydride, benzoic anhydride or methyl anhydride or any anhydride, and add water. Everything is like hydrolyzing. whatever, which all compound we hydrolyze, maximum we will get into the what? Now if we hydrolyze the acid derivative, we automatically get into acid. That's the concept. Okay. Now we get C6H5COH accordingly. C6H5COH. That you know. If you are taking some other anhydride, benzoic ethanoic anhydride, that is COOCOCH3. Here we use 2 benzene, here 1 CH3, 1 CH. What happened? Here two things will be formed, that is C6H5COOH plus CH3COH. Ethanoic acid and benzoic acid is formed. This is the thing. Okay, simple. Now next method is from ester. So once again this ester has come. Take an ester. Also what? Ester is also an acid derivative. So whenever we hydrolyze acid derivative, we get the acid. Take ester, that is C double bond O C2H5, something like this, and what? Hydrolyze H3O plus. We get COOH plus C2H5OH. This hydrolyzing means what happening, you know. Esterification was a process of adding one acid and one alcohol to form ester. The opposite way we did. The opposite thing, what we reversed the reaction, we got what? Once again we got the used acid and the alcohol. Simple. If you are taking any other method, what? CH3, CH2, CH2, COO, C2H5, and you are adding what? NaOH, what's anything, you add something, one base, you add one base, and if you hydrolyze, if you are adding one base, if you are adding one base, we get the corresponding salt of that base, as we got in Cannizzaro reaction. Then after that you hydrolyzed the salt, hydrolyze it, then also we get what? The corresponding acid, CH2, CH2, COH, corresponding acid. Simple. So by this, preparation of these compounds are over. Preparation of acids come to an end. Preparation of acids come to an end. Only 5 or 6 methods are there. Now chemical reaction. How many chemical reactions are there? Only 2 or 3 pages. We'll get it over fast. This part will be short. Chemical reaction. So as we did in alcohol, there are 2 types, OH bond cleavage and CO bond cleavage. First, OH bond cleavage. So that is showing the acidic character. You know that carboxylic acid is an acid. So automatically, for sure, carboxylic acid will react with the base. To give the corresponding RCOONA, salt plus water. You know, carboxylic acid also react with metals as phenol does, or as alcohol does. Alcohol react with metal to form corresponding phenoxide, sodium phenoxide, sodium or alkoxide, etc., etc. So here also what we'll get? Sodium carboxylate. What? One second. Na. We get RCOONA plus we'll take 2Na. 2RCONA plus H2. Sodium is what? Sodium carboxylate. So this reaction is possible because the acid base reaction, or metal acid reacting with metal. Okay, this is the thing. Understood? Yes. Now many things is written about acid character. Time loss. Acid characters are time loss. I'll just explain. Look, RCOH, that never happened. You are having RCOH. Okay, you are having RClCOH, which is more acidic. This is more acidic because it's an electron withdrawing group. R's plus psi effect is what? Plus psi effect less due to what? Electron withdrawing, EWG. Therefore this is this oxygen is more electronegative. So what is happening here? This is what more Acidic. Acidic. Same as we did in phenol and alcohol. Same. Okay. So I'm asking, benzoic acid is more acidic or what? CH3COH. Yeah, benzoic acid is more acidic because resonance, partial double bond character. Yeah, very simple. This is the thing you understand. If NO2 come here, and we have a normal benzoic acid, which is more acidic. This is more acidic. Why? NO2. Electron withdrawing group come, that means that acidicity more. You understand, electron withdrawing group is directly proportional to acidic character. If electron donating group come, that is a CH3 group or a OCH3 group, etc., then what happen? Electron donating group come 1 by acidic character. This thing you by heart is very simple to do for everything. This is the thing on that. Now they have given many other about matter structure, then why is more than phenol, this and all. Read the textbook, you will understand. It's very simple. This thing you understand. Electron withdrawing group come, acidic character increase. Electron donating group come, acidic character decreases. That's it. Electron withdrawing group, acidic character increase. Electron donating group, acidic character decrease. That's it. Now COH bond cleavage reaction. Stop. Now the other OH bond cleavage reaction is only one, that is acidic character. Now COH bond, that is formation of acid derivatives, that is formation of anhydride. Nothing, two acid join together to form an anhydride. That's the basics. Two acid join together, that is I'm having one acid CH3. Acid anhydride means hydrogenless acids. They are called acid anhydrides. CH3. We are taking carboxylic acid, and we are adding the reagent, that is H plus heat or P2O5 heat, anything H2 such as H2SO4 you can add, acid you can add, or P2O5 and heat it. Any one of this water reagent. What happens is that H2O go away, minus H2O, and we get the compound as CH3, C double bond O, C double bond O, CH3. This is called acid anhydride. Acid anhydride. Okay, simple. Just remove one H2O and join the oxygen. That's it. Now second reaction is esterification. I'll just only write the reaction, I will not explain it. When an acid and when an alcohol react together in presence of an acid, a fruity smell is evolved, that is an ester is formed and water is formed. This is the same thing as what repeated. Refer alcohol part, that is part 2 video. Okay, part 2 video. Refer part 2 video. Now third one, reaction with PCl5, PCl3 and SOCl2. By seeing this thing itself, we can understand what is this. Formation of what? Acid chlorides. The reaction is same as what we did in haloalkane halorine. It is like RCOOH plus PCl5. We get RCOCl plus POCl3 plus HCl. Okay, first reaction. Just learn this. Second one, RCOH. This is 3RCOH plus PCl3 gives us H3PO3 is there plus 3RCOCl. Okay. Now last one is RCOOH plus SOCl2. We get RCOCl plus HCl gas plus SO2 gas. This reaction is a more preferred. Why preferred? Why? Byproducts escape easily because they are gases. So we get pure ROCl. This is most preferred. Okay. Now fourth one. Now we told about what acid, anhydride, ester, what chloride. Now we have amide. Okay. Now we are talking about reaction with ammonia. Formation of amide. Okay. We'll take CH3COH and we add ammonia into it. First of all, we don't get an amide. We add ammonia. We get a salt, that is CH3COO minus NH4 plus. This salt is called ammonium acetate. Okay, perfect. It is then heated and water is eliminated, that is CH3CONH2. We get this compound. Simple. So now we are taking another compound, that is this thing COOH. I am adding one NH3, then I am heating it off. What am I getting? I am getting C double bond O NH2 amide. C double bond N. So there is a salt formed in between. Don't forget ammonium acetate. Here we will get ammonium. What's the salt we are getting here? We are getting, this is the salt that we are getting. Salt is ammonium benzoate. Okay, ammonium benzoate. Now there is a funny reaction in this. You are taking this compound, that is dicarboxylic acid, 2 carboxylic acid, and you are adding NH3. sorry, I'm talking for a long time. How many hours? 1, 2, 3, 4 hours I'm talking. I'm not well. I'm not, my throat is not allowing me. 1 second, let me take 1 minute break. Okay, no need a 1 minute break. I'll just end it and I want to sleep. I'm not well. Okay, so when we take this and NH3 is taken, we get this thing, CO minus plus NH4 plus. Salt formation is happening. COO minus plus NH4 plus. Perfect. Now when we heat it, we get the corresponding amide, that is NH2, and here also we get CONH2. Now this corresponding amide is strongly heated, very strongly, that is 3 times delta heated. What happened? Do you know what happened? NH3 will leave, that is NH, here one H is standing here, this NH3 will leave, minus NH3. The left will join together, that is left will like C is here, double bond O is here, here one C is here, double bond O is here, the left NH will join like this. This is called phthalimide. This thing is used for Gabriel phthalimide synthesis. That will be coming up in the amines chapter. Okay, this is called phthalimide. This preparation of phthalimide is important. Okay, important reaction. This is important for board exam also. This is important for board exam. It's more important. Okay. This is it. Now reactions involving COOH group. Now which all group did we tell? Yeah, now we told about COH group breakage we told. Now OH group breakage we told. Now we are talking about what? Now we are talking about COOH RCOH group bond breakage. Bond breakage reactions. That is one. Reduction. You know that if you reduce an acid, you get what? Corresponding alcohol or corresponding hydrocarbon respectively. So first one is reduction to corresponding alcohol. Take it, LiAlH4. It is expensive, still we'll use it. Okay, and H3O plus. You can use LiAlH4 in ether medium, or one more option I am giving you. You can use B2H6, that is diborane. You get RCH2OH as a compound. This is the reduction. Now second one is decarboxylation reaction. Carboxylation. This reaction is having another name, that is Kolb's electrolysis. This reaction is there in hydrocarbon chapter 2. Only this thing is that we are taking RCOONA, that is a salt of carboxylic acid, and we are heating it with NaOH and CaO, calcium oxide, and sodium hydroxide, and we are heating it. We get corresponding hydrocarbon and Na2CO3. The thing is that, the important thing is that this thing I know you can remember. NaOH and this calcium oxide are taken in a specific ratio. This is very important. 3:1. This is important. What ratio they are taken? They are taken in 3:1 ratio. They are taken in 3:1 ratio. This reaction is called what? Kolb's electrolysis. We are getting directly the hydrocarbon, and NaOH and CaO is taken in 3:1 ratio, and this is about Kolb's electrolysis. Now next set of reaction, that is substitution reaction in hydrocarbon part. Here COH group is not involved, only the hydrocarbon, that is R group is involved in hydrocarbon. Example are HVZ reaction. First one is HVZ reaction. HVZ reaction. For HVZ reaction, the most important thing is that alpha hydrogen, like what? Aldol condensation. Here also alpha hydrogen is compulsory. If there is alpha hydrogen in a compound, in a acid, taking it RCH2, here alpha hydrogen is there, COH, then if we add phosphorus, X2 and red phosphorus, and I am hydrolyzing it, adding water to it, I get CHX, I get alpha substitute, alpha halocarboxylic acid. I am getting alpha halocarboxylic acid as the project. This is important. The thing is that alpha hydrogen, they can ask you questions like, they'll give you 10 compounds. They'll give you something like this: COOH, HCOOH. They'll ask you HCOOH, CH2COOH. In these three compounds, they'll give 1, 2, 3 and 3 marking. HVZ reaction is given by option A 2, 3, option B only 2, only 3, option C only 2, option D 1, 2 and 3. What's the answer? Here only this don't have alpha hydrogen, this don't have alpha hydrogen, only this is having, that is only this 3 is having alpha hydrogen, so only 3. Option B is the correct answer. So these questions will be asked. Okay, Only these type questions will be asked. Now second type, that is ring substitution. Ring substitution. Here also look, this compound RCOOH. I told you that. One second, sorry. I'm telling you something now. RCOOH. This compound is deactivating because carbon attaches to electronegative group. So this is a deactivating and meta-directing group. So all the electrophilic reactions will be meta-directing. So first reaction we are going to deal is COOH, concentrated HNO3 plus concentrated H2SO4, that is nitration. Here NO2 go and join at the meta position, not para or ortho, meta position. Okay, this reaction. Now halogenation, COOH. Here Br2 FeBr or AlC, anything, FeBr3, we get COOH and at meta position Br. Okay, so these are meta-directing group. Carboxylic, benzoic acid is a meta-directing, so therefore meta substitution occurs. Here no Friedel-Crafts reaction occurs. Why? The reason is that the catalyst AlCl3 gets bonded to carbon. Because carbon is electron rich, right? So AlCl3 being a Lewis acid gets bonded to the carbon. That is the reason why Friedel-Crafts reaction does not occur here. Okay. Yes. So by this, the carboxylic acid part, all the chemical reaction preparation has come to an end. Now next video will be on amine. With that, this all organic reaction part will come to an end. Thank you. Please like, share and subscribe. Don't forget it. Thank you.